Hi, scholars. Today we are going to continue our circuits investigation. So yesterday we spent the majority of the day reading some background information to help us with our investigation proposal. And today we're going to be spending time perfecting our procedure and also collecting data. Right, so the purpose again behind that is to be able to answer this guiding question of how do conservation laws apply to simple series and parallel circuits. Right. So before we start collecting our data, there's two important things that we need to know. So how is the voltmeter added to the circuit in order to collect data? So again, remember the voltmeter is something that we use to measure the voltage within the circuit. And then how is an ammeter added to a circuit to collect data as well? Right, so take the next minute to answer these questions in your classwork document. All right, so let's move along. I'm actually going to show you in using the FET simulation that we're going to be using today so that it's super clear. So here I have two circuits that I already built. I have a parallel circuit here, it has two light bulbs, and then I have a series circuit here. So in order to use our voltmeter, which will measure voltage, I am going to click on it from my toolbar over here and drag it over. Right, so in order to use the voltmeter, I have to connect it in parallel, meaning I have to connect it around the thing that I'm trying to measure the voltage. Right, so if I put one probe on one side and another probe on the other, over here it's going to tell me how much of a voltage drop is here in this light bulb, right? And then I can put it across any part of my circuit and it will give me a reading here. The only part where it won't give me any reading is if I put it just within the wire. And so remember, for a voltmeter, it has to be on either side of a proper circuit element, either a light bulb or a battery itself. All right, and then I can just click this and put it back into my toolbox. And I'm going to grab, there's two types of ammeters here. The easiest one to use is the one that has this probe. And then for this one here, all you have to do is put this finder directly over a wire. And it will tell you what the current is throughout that part of the wire. Right, so you can use this to measure the current in different parts. Over here as well. So you see, depending on where you place your wire, it will tell you the reading of the current. Okay. All right. So just as a quick summary, a voltmeter you connect it in parallel, so it's supposed to be on the other side of the circuit. You can add this into your classwork document so it can help you guide you while you're doing your investigation. Right. And then an ammeter is connected in series, or what that means is that you can just put it anywhere on top of a wire and it will measure the current. You can add this into your classwork document so you can help use this to guide your investigation. Okay, so before we start collecting data, we have to make sure we have a proper procedure. So yesterday in your proposal, you should have already highlighted a procedure that you want to follow to answer the question. So I just want to clarify a little bit more about it. So writing a scientific procedure has to be, you have to be clear, and it has to be direct, and it has to be concise. Right? So these are really important points. So we're just going to look at a bad example and a good example of a scientific procedure to bring a little bit more clarity. For example, a bad example would be something vague like get supplies, plant seeds, set temperatures, water plants, and so on. Right? So this would be a procedure for planting seeds into soil. Right? But a more specific one is like this. So you gather all the listed materials, place the 2 kilograms of soil in each of the 5 pots, carefully place 5 seeds in each pot and evenly distribute throughout the soil, and so on. So we see here how this the second example is a lot clearer, and it's a lot more direct, and it's concise. Okay, so keep that in mind. There is a there's a procedure rubric that you will be using to grade your procedure for this lesson. You should use this rubric to help yourself, to guide yourself through writing your procedure. This table is in your classwork document as well, so you can refer to it there. There are some questions that are helpful for you to consider while you are before you start collecting your data. Again, these are also in your classwork document, and you should take a few minutes to answer these before you start collecting your data to help you visualize how you're gonna be doing this. Right, so what will you look for in your data to answer the driving question? How will you display your data in a way that's easy to see patterns? So that's really important. How are you going to write out your data? And think about methods that we used in class before to help guide you through that. If charge is conserved in a circuit, what do you expect to see in a series circuit, and what do you expect to see in a parallel circuit? What about if energy is conserved? Right, so you read about the conservation of charge and energy yesterday. So how is that going to be affected by these two different types of circuits? All right, so for your classwork for today, you're going to answer the questions to consider in your classwork document, and then you're going to take the remaining of time to complete writing your procedure and collecting data on your classwork document. And once you're done, you're going to submit that through Google Classroom. If you have any questions now, you can ask your teacher. If not, good luck. Oh, one thing I forgot to mention is it would be really helpful for today's class is if you open your investigation proposal from yesterday. So in Google Classroom, you are going to have to unsubmit it so you can open it up again and use that to help you with today's investigation. Right, so that was the purpose behind yesterday's lesson, is to prepare us for today. So you're going to need to refer to your classwork from yesterday to be able to be successful in today's lesson. Okay, well, that's all, and I hope you have a fantastic day. Good luck.